All right, 81. I've got a graph of a derivative here. Which of the following could be the graph of f? So these are the slopes. So there's only 4 choices here, so you could kind of work backwards. That's a little bit easier, maybe. You could look here and say, okay, if this is the derivative, this is a function that all of the slopes here, when x is negative, all of these slopes are positive. So this is a function that is only increasing over here. All of the slopes are positive. So this is increasing over here. This one's not. This one has negative slopes here, and there's no negative slopes here. And likewise, this is decreasing, so that's not right. So these two look like they're contenders here. If you want to, this is a minimum of the derivative. The derivative goes from decreasing to increasing, so it should look like there's an inflection point somewhere near x equals -1. And that looks plausible. And here, this one looks more like the inflection point. Well, no, that looks plausible too, somewhere in -1. So that didn't really help. Okay, well, here's the derivative. This derivative goes from positive to negative here. So that function must go from increasing to decreasing here, or in other words, have a maximum at 1. And this one does not. So it's got to be A. So that's, I don't know, I think that's a pretty straightforward problem if you just go slow and do what you know. All right, at time t equals 0, a tank contains 48 gallons of water. So that's important. That's an initial value. I bet you there's a wrong answer for forgetting that. For time 0 to 4, water flows into the tank at this rate, and water leaks out at this rate. How many gallons are in the tank at that time? So I've got 48 gallons to start, plus all the water that came in, minus the water that's going out. Now, we've done problems like this before, so I need to set up that integral in my calculator. Let's get right to it. So let's see, I've got 48 plus the enter function, the integral of that from 0 to 4. And you know what, I think I'm still, let me get out of, I don't want to see thetas here particularly, so I'll get out of that polar mode from a couple problems ago. So the enter function is 12x times the sine of pi over 4 times x. If that looks like pi over 4x to you, that's not what the calculator thinks. The calculator thinks pi over 4 times x. So that's what we want. Dx. And then I want to subtract. Oh, I did it as, you know what? I can do this all as one integral, like that's minus, because the limits are the same, right? 0 to 4. And then here I've got 6t squared, 6t squared over the quantity, you need the parentheses around this or you will get it wrong, x plus 2 dx. That should do it. 82.749 looks like it. And they don't have the one that's 48 less than that. That surprises me that they don't. But they don't. So 84 is answer choice B. Number 85. What's the average value of y equals the tangent of x squared over 9 on this closed interval? Did I skip a page or something? No, or am I just going faster? I guess I'm just going faster through these. 81. No, I'm missing. Oh, I'm missing a page. Dang it. Copy machine ate a page again. I'll see if I can look those up for you because I will get you that page. So I'm missing 82 and 83. I'll try to double back to those in just a sec. What's the average value of y equals tangent of this? Okay, so average value of a function from 1.25 to 2. The average value of a function is the integral of that function from wherever to wherever, divided by how wide the interval is. So this interval is 0.75 wide. Oh, that beetle's on my shirt now. He likes me. So that's easy integral to set up and evaluate. I'm going to do math 9, 1.25 to 2 of the tangent of x squared over 9 dx. And I want to divide that whole integral by 0.75. And that's 0.310, this right here. And that's that. All right, so on my computer here, real quick, I'm going to try to scroll back to, what did we miss, 82 and 83. Let me see if I can try to quickly find those. Let's see. This is a long document. There's a lot of other extra stuff in it, so give me a second here. And you'll have to refer to yours. I'm not going to have a copy of this now. So, okay. 82, on a certain day, the total number of pieces of candy produced by a factory since it's opened is modeled by C. So the total number of pieces of candy is modeled by the function C. A differentiable function of the number of hours. So this is C of t, where t is in hours. Okay. Which of the following is the best interpretation of the statement that C prime of 3 is equal to 500? I'm not going to look at the answers yet. So this is the derivative. That's the rate that candies are being produced at time 3. So the rate that candies are produced at, that would be in candies per hour at time 3 is 500. So factory produces 500, so A is not right. Factory produces 500, that's not right either. Or B, or answer choice B. See, the factory is producing candy at a rate of 500 pieces per hour, 3 hours after it opens. That's correct. Answer choice C. And D, the rate at which the factory is producing candy is increasing at a rate. That's the D is kind of like about the second derivative. The rate that they're in, the rate is increasing at a rate of, that's like a second derivative thing. So C is the correct answer there. Number 83, we've got a graph here. Sorry, I don't have to show you. Graph of the function f is shown above. Which of the following statements is true? All right, so first choice, f is discontinuous at x equals 0. That's true, because the limit as x approaches 0 of f of x does not exist. That's not true. That limit does exist. There's a hole there, which means the function is not continuous, but that limit does exist because they're coming into the same thing, that same hole on both sides. So it's not A. B, f is discontinuous at x equals 3. That's true because there's a hole there, because the limit as x approaches 3 of f of x is not equal to f of 3. That is the correct answer. As if something's continuous, then the limit, whatever it's getting closer and closer to, it actually needs to be that, right? If the function's going to smoothly go through that, I shouldn't say smoothly, if it's going to, without a whole jump or vertical asymptote, go through that, then the point has to be in the right place. So B's looking good here. I'm going to go ahead and even write that down. But let's talk about C and D. F is discontinuous at x equals 5 because the limit as x approaches 5 from the negative sign of f of x does not exist. Well, those one-sided limits always exist. It does exist, and that limit would be 4, right? X approaches 5 from the negative side, it's coming into 4. So that's wrong. And D, f is discontinuous at 6. I'm just going to stop right there. It is continuous at 6. There's a sharp corner, but that doesn't stop it from being continuous. That would stop it from being differentiable. So answer choice B is correct. All right, let me scroll back down to the other page that I need to be on so I don't make sure I don't give you any wrong answers. It will take me just a second to get there. Scrolling. Oh, there we go. Okay, so 82 and 83 CB, we're all good. And we'll stop this video there.